Good morning, dear students. From today, we'll be starting our classes. My name is Atom Santi. In short, I'm being called as AS, and I'm your physics teacher. In physics department, we have two teachers. One is Sir Joshua, and the other is myself. So Sir Joshua will be taking up from the unit number 1, that is units and measurement, and I myself will be starting from gravitation. Okay, we may not be able to have all the facilities that are available in the classroom, but in these online classes, I'll try my level best to give you the very best through this camera, through this the electronic media, and the notes that are supposed to be sent as PDF or maybe as a web page. So what you have to do is you just go through the notes first, and after you go through the notes, you come back to the video section, because the video is meant for explanation of maybe the derivations or some calculations that are included in the notes here. Okay, then let us continue our class. Alright, dear students, I will be starting our class right now. In today's class, we'll be starting from gravitation. First, we'll try to know what is gravitation. Gravitation refers the force of attraction between two different bodies which are separated by a distance here. The laws of gravitation, as given by Isaac Newton, it says that if you have two mass, one is m1, the other is m2, which are separated by a distance of r, keep in mind that the separation should be from the center to center, then there exists a force of attraction here. The force would be attraction. And Newton says that this force of attraction is directly proportional to the product of the masses here, that is m1 and m2. It means if these two masses are becoming bigger in size, the masses are increasing, then what happens? The force also increases. It means they will attract more. Between two smaller bodies, the force of attraction is small because these two are small masses, whereas in bigger bodies, the force of attraction is larger, simply because the mass is large here. And he also says that this force varies inversely with the square of the distance here, r square. As we know in inverse relation, whenever you increase this r, f decreases. It means if you keep the two bodies very close means r is very small. That is why the force will be very strong here. So in this case, the force will be very, very strong. On the other hand, if you keep the two bodies separated, it means the distance r is quite large. So if the distance r is very large, the force becomes weaker. So the attractive force is very weak here. So this is the law given by Newton. So if you combine the two laws, it becomes F is directly proportional to m1, m2 divided by r square. Or F is equal to a constant z, m1, m2 divided by r square. Keep in mind that this z comes from the relation. So this equation is what we call as the Newton's laws of gravitation. Now, Newton's laws of gravitation is very popular, especially when you talk about the microscopic bodies, maybe even in the smaller bodies as well as the bigger bodies. Whenever you talk about the force between them, this force of gravitation should be always there. Okay, then we'll try to understand what is this z here. In the equation, F is equal to z m1 m2 divided by r square. We have this. If you have these two mass, m1 is suppose 1 kg, m2 also 1 kilogram, and the separation r is equal to 1 meter. Put it here. Then what F becomes z. I'm going to put m is equal to 1 here. 1 kg, m2 also 1 kg divided by the separation also 1 square, 1 meter. Everything is but putting the value of 111 here. Then F becomes equal to what? Z. Then the question is, how do you define this G? Now you can say the universal gravitational constant G, this will be defined as the force. What type of force? The force of attraction that exists between two masses, each of 1 kg, this also 1 kg, which are separated by a distance of 1 meter. I repeat one more time. The universal gravitational constant G can be defined as the force that is defined as the force of attraction that exists between two masses, each of 1 kg, separated by a distance of 1 meter. Imagine you have two mass. This is 1 kg, 1 kg. Keep them 1 meter far. Then there should be a force of attraction between them. So that force of attraction will be defined as universal gravitational constant. Okay, this is the definition. So I advise you to go through the notes. Everything is written there, and this is just for explanation, and this video is not going to be long. Okay, then let us see the unit. From this equation, you do cross multiplication. From here, you cross multiply, you will get Z m1 m2 is equal to F r square. Then what Z becomes F r square divided by m1 m2. Now, as we know, force stands for Newton, force, F for force, and the SI unit of force is Newton, and R for the distance. This is in terms of meter, and the mass is in terms of, what is it? Kg, yes. So instead of this force, you can write this Newton, R for the distance. The distance is written as meter. There is square, I write square here, divided by how many mass we have? We have two mass, one for kg. So it becomes what? Kg square. So you can write Newton meter square per kg square. This is the SI unit of Z. And there is one numerical value of Z. The numerical value of Z, this is equal to 6.67 into 10 power minus 11. After that, you put the SI unit again. So it becomes nm square kg per kg square. This is the exact value of G that you will be using many times during numerical calculations and all. Okay, this is all about the value of Z and the SI unit. Next, we'll see the laws of gravitation in vector form. In the vector form here, consider two mass like this. This is your m1, this is m2. The separation as before, this is equal to r here. Imagine that these two are attracting each other. Suppose say this m1 is attracted by m2. Say this is moving right now, being attracted. Something like I'm here, I'm pulling this one in this direction, pulling like this here. That's why the force direction should be in this direction. So you can point like this. This is what F. The force is exerted on one. Something like the one moving is nothing but one here. Who is pulling this mass? M2 is pulling. So you can write F12 here. Simply, it means that if you write F12, this is the force attracted by M2 on M1. Like this. Something like, just imagine my body is M2 and this is M1, so I'm pulling like this. I'm pulling like this. So this pull, let it be F12. Similarly, if I stand here and I pull this mass in this direction, the direction of the force will be here. So it will be going like this. So who is coming right now if I pull here? This M2 is coming. So F21, you can write. You can give the arrows right now because this will be in the vector quantity right now. Okay, then you need to have another unit vector. This is known as position vector. For example, say, where is M2? M2 can be found from M1. So from M1, if you look at M2, there should be another unit vector, R. It goes from 1 to 2 here, R12 cap. Do not get confused here. This R12 is just used to find the position of M2. For example, this is your M1 here, this is your M2 here, and you are searching M2 from M1. So if you're searching from M1, just trying to know where is M2. Something like, I'm M2, this M2, I'm M1, this is M2. Just searching where is that. I need to start searching from the first one towards the second one. This is the R12 here. This is the meaning. Similarly, if you want to find where is M1, starting from M2, you need to have another unit vector, R starting from 2. So you can write R2, it goes to 1 here, like this. Okay. So now you have two equations. So you can write F, you can select any one of them here. You can write F21, this is equal to, from the equation, Z, the two mass is M1, M2 divided by, the separation is R. As I told you, the distance is going to be R here. So it becomes R square. Okay. Then you choose the unit vector having the same direction with this F21. F21 is directed towards the left. So between the two here, between the two, the one directing towards the left is nothing but R21. R21 goes in this direction. So I write as what? R21 cap here. So you can call equation number 1. And similarly, you can write F, the other one, F12. F12 is equal to Z M1 M2 divided by R square. So in the same direction of F12. F12 in the same direction of M12 is nothing but your R12 cap here. R12 cap or R12 hat. So this is equation number 2. So any one of the two equations, 1 or 2, will represent laws of gravitation in the vector form. But you know that R12 cap is equal to minus R21 cap. This is from vector algebra. You will be studying later on. But just for time being, remember this formula. So you can put this one R12 in equation number 2. So you can write using into, if you put in the second equation, you have this F12. This is equal to Z M1 M2 divided by R square. So instead of this R12 hat, you can write minus R21 hat or cap. Okay, then this equation will be transformed like this. Next, you can write minus here Z M1 M2 divided by R squared and R21 cap again. So now observe this equation without the negative sign. If you observe this portion clearly minus M right here, it clearly indicates equation number 1. So we can write F21 vector. Therefore, the conclusion is F12 vector is equal to minus F21 vector. It means these two forces, the two forces, one acting here, these two forces are equal in magnitude but opposite in direction. So this is nothing but your Newton's third law of motion. Okay, I'm just doing the class in a bit faster way because I need to save the time, because video takes lots of data and I find very difficult to send it to you, so I just make the video a bit short. So I hope that you understand what I'm teaching, though it may be a bit faster. So you keep on playing the video repeatedly and you'll be able to understand what I'm teaching. Okay, then this much for today's class, and I suggest you one more time, you go through the notes. The notes are better in the sense that it covers more portion, more areas. So you please go through the notes, and after that you come back to the video again. Okay, then see you in the next class again.